running a few minutes late. I guess the keynote was very exciting, and so it kept going. So we'll see if we can fit all this in here. But today, I want to talk about modularity in Java, in particular OSGi, and things that happened in Java 9. So you've probably heard of Java 9, and the Java 9 came with a big new feature, which is the Java Platform Module System. And so I'm going to talk a bit today about some of those changes, what they might mean for OSGi, and things we've done in the OSGi spec around Java 9, not necessarily just about Java Platform Modules, but other changes that came in Java 9 that were sort of precipitated by the Platform Module System. So, of course, the big, sort of the headline feature of Java 9 was the Java Platform Module System. So who here has written a Java 9 module? Okay, so we got a few people, so you've had a play with it. And sort of the, OSGi, if you're here, you probably work with Eclipse, Eclipse uses OSGi. And so OSGi has been doing sort of modularity for a long time, right? We started back in 2000 with our first release, and the basic architecture that was put in place in 2000 still exists today in the OSGi spec. So we do modularity, we have some experience with it, and in fact, a lot of the OSGi peeps gave a lot of input into Java as they sort of tripped along and fell and stumbled and eventually ended up with Java 9 and the Platform Module System. So JPMS basically was primarily focused, right? The requirement set that ultimately led to the Java Platform Module System was the primary target was modularizing Java platform itself, right? Oracle had a goal, and that goal was to modularize the classes that make up the Java platform, right? Java Lang, Java X, this and that, and the other things, right? Because for a long time, Java as a platform was basically a big open monolith, right? How many people here have written to some class in sun.something or com.sun.something because it was easy to do, it was there. You could just call it from your code. And so over time, right, they begin to accrete a lot of details in the platform, and a lot of people begin to depend upon those details, and it makes it very hard then to evolve the platform, to change the implementations of things, because people began to couple to those implementations, right? It's the same reason we want, in our applications, want to modularize. We want to encapsulate our implementation details so that people can't become dependent on them to the extent that we can't improve our implementations. We can't replace them with better things. And so this is a great goal, right? This is certainly something that had probably been needed for a long time, and it also gives the benefit because of that once they modularize the platform, you can subset it reliably, right? You can J-link down your platform to some subset of the modules for a particular application environment, because you can do the analysis, you've done the isolation, and it's easy to subset it down. But the other thing that happened when they defined the platform module system is they sort of opened it up for application developers too. It says, hey, it's not just for us in the platform to modularize the platform. You, the developer, can also modularize your jars. But the problem is, much like people have had, in the sort of Java world with OSGi, it's not easy to take your existing code base and run it in a modular environment, right? Because people make all sorts of assumptions, and when your tool chain and your development processes don't encourage you to, and even enforce you to be modular, you often aren't. Right, in the OSGi community, there's a famous quote from John Wells, right? We thought we were modular until we actually enforced it, and then we realized what a mess we had. You might think you are something, but until somebody enforces it, you don't really know that you are something. And the other challenge, right, and this is, again, the same challenge OSGi has faced over the years, is until everybody, starting at the bottom layer, begins to modularize, it's hard to build up a totally modular system. So you use some open source project, you want to bring it into your OSGi application, but that project didn't pay particular attention, so they're busy class renaming all over the place and expecting things to work, and they don't when you encapsulate. So all these same challenges that OSGi has faced over the years, Java platform modules are going to face too, right? Until all the loggers and all the bytecode analysis libraries and all these sort of leafs, things that don't themselves have other dependencies, until they start to modularize, you can't begin to lift up the system as a whole, right? Until Maven Central begins to fill up with modules, it's going to be hard for your applications that sit on top of, tens or hundreds of third-party dependencies can become modular. And even in OSGi sense, we're getting a little better with people putting metadata in, but it's not all there. The other issue, I think, from an OSGi perspective, is that JPMS sort of really falls short in some key areas for applications, right? The requirements they put in place for JPMS are suited for the platform, but they're not necessarily suited for you as an application developer. Right, so the Java platform basically releases as a big single release, right? So all the modules are built together in a build, and they all release together. So versions aren't important, right? Because they all come together from one supplier at one time out of one build. And that works really well. But of course, what application ever is done that way? Applications are composed of many modules from many providers, released at many different times, and this all has to work together. And that's really hard because when you depend on a thing and he depends on some other thing that you also depend on, how do you know they're all at the same version even, right? They might be different versions, and that's a huge issue as you begin to assemble a large and complex offering from a variety of different parts that all sort of have a nicely interconnected graph of dependencies. These don't all come out of one build like Java does. So what are the main shortfalls that cause problems in this space for applications? So the first one we see is basically isolation, right? One of the promises of modularity is encapsulation, isolating your implementation details. So in the OSGi case, we built upon the primitives that exist in Java, and primarily that's class loaders. We use class loaders to do encapsulation through type visibility hiding, right? You can only import the packages that someone else exports. And so that works fairly well. But in a traditional sort of JPMS world, you put a bunch of modules on the module path, and while each of them have their own module, they're all basically living together in one class loader. So that solves some issues because you don't have to worry about the hiding that different class loaders get you, but it does create other issues in that your private packages, your non-exported packages, sit in conflict with everybody else's non-exported packages. And so you have to be very careful when you pile a bunch of modules together in the module path that you've all carefully not attempted to use the same package name. Another key thing is identity dependency. You basically require a module by name. You don't really require the things you actually use, which are classes that live in packages. You require a module by name, when really that's not what you require. It's just the package that you saw it come in at the time you built your code. But a class could potentially come from any source. And in fact, if you look in your bytecodes, what's in there? There's just class names in the constant pool. That's what you depend on. Access restrictions, right? As I mentioned, OSGi uses type visibility hiding through class loaders to give its modularity. But the primary mechanism in the Java platform module system is not class loaders, right? Because of course we put all these modules in the module path together in one class loader, and what they do is they use the access mechanisms of the JVM to enforce encapsulation, right? So we're all familiar with public and private and protected and package private, default access. Well, there's another layer added to that access check in the Java platform module system, and that is, are we in the same module, or does your module, do I have read access to the other module? Because I can't call your public class in another module unless you've granted read access to it by requiring the module. So that's works for the basic code, but then the complicated and important things we often depend on don't work sometimes, like dependency injection. Who here doesn't use dependency injection? No hands, right? So everyone cares about dependency injection. And dependency injection basically works because it breaks the encapsulation walls. right? That's its basic premise, right? It starts rooting around through your code looking for annotations to inject things into private fields and call constructors and do other things in your implementation details, not in your public API. So the basic design principle that they use for encapsulation in Java Platform Module System flies against dependency injection and other sort of similar mechanisms. And of course, versioning. The Java Platform Module System says nothing about versioning, so that's someone else's problem, yours. All right, so I've sort of highlighted some of the key differences between what OSGi does for modularity and what the Java Platform System does. So in OSGi, we did Core 7 just recently. Now, we don't have a story in there about interop with Java Platform Module System, but there were some other features that came in Java 9 that we had to reckon with, and we dealt with in R7. And so we'll talk a bit about the support that we have in Core R7 for these Java 9 aspects. So these are the basic headlines. Java 9 added multi-release jars. It now really supports the runtime discovery of all the packages that will come in the platform. And of course, bundles can now import Java star packages. But of course, the key thing is that even though we added this support, all of the stuff that existed in the past still works today on Core R7. We're fully backwards compatible. So who here has heard of multi-release jars? Who here has written a multi-release jar? Other than as an experiment. So no one's really used multi-release jars in anger, have they? So this was a concept that was created in Java 9, basically in an attempt to deal with the fact that of course, the main reasons they modularized the platform is they wanted to begin to hide implementation details, right? They wanted to take your sun, misc, unsafe away from you because it's dangerous. And so as they begin to do these things and peel away implementation details, you have to write your code differently for Java 9 or Java 10 or Java 11 once they take this away, because you have to implement in an alternate way on that platform. But of course, that future new way doesn't exist in the old platform, so you might have to have two versions of a class, one for Java 8, one for Java 9. And so the multi-release jar was a mechanism that lets you deploy multiple versions of a class and let the system pick the right one at runtime. And so its real purpose here, again, is to support these alternative implementations, the Java 8 way or the Java 10 way, really not as a way to have different functions on different platforms, right? Not to add more features than Java 9. And so the way you become a multi-release jar is you have to put this in your manifest, multi-release true. And once you say that, then Java 9, Java 10 will look at your jar in a slightly different manner. And so if you built a multi-release jar, it might have contents that look like this example here, right? We have our manifest that everyone knows, and inside there it says multi-release true. We'll have some classes, we'll have some properties, limited directories, and then we'll have this new folder in meta-inf called versions. And underneath it, there will be different directories with major version numbers in them, 9 and 10 and 11. And then we'll have alternate files that sort of can replace the files that exist in the sort of the base of the jar. So if you're Java 8, if you try to run this jar file in Java 8 will basically see the things in blue. It'll see that version of the bar class and that version of bar properties, and that's what it looks like for Java 8, because Java 8 doesn't know anything about multi-release jars. But if you ran this jar in Java 9, it would see different things. It would pick this bar class instead of the bar class in the base of the jar. Java 10 would be a slightly different view on things, because it would start at 10 looking for things, and so it would find the properties in the versions 10 folder, it would find the class in the versions 9 folder, and then Java 11. And so basically this goes on forever and ever and ever as they add new versions of Java. But I'm hoping at some point they finally stop peeling all of the things out of the base platform that they want to hide, and then we can end this madness. But of course, the reality is these things could exist, right? So even though you've heard of them, you've never built them. And the reason you probably never built them is because they're impossibly hard to build. There's virtually no support in Maven or Gradle to build these things without writing a lot of custom magic POMs and Gradle scripts. It's ridiculously hard to do. But you never know, so they might exist, and so the spec should support them. So we have this concept in OSGi of supporting them. So we have these things we call multi-release bundles. So if we encounter a bundle, and that bundle has the multi-release true manifest header, we'll say, okay, got it, we can understand that. So there might be things in these version folders. And of course, the other thing is that these, because you're writing alternate implementations to run on the later versions of Java, your class might have other packages that it needs to use, right? There might be some new Java class that's added to replace the thing you used to do with sun, misc, unsafe. And so you might need to import that class into your bundle. And so we have the concept of a supplemental manifest, right? And in the supplemental manifest, you can have alternate versions of import package and alternate versions of required capability, because you might need to import different things or require slightly different things to do your job, because you're maybe replacing something with a service loader thing. And so basically the framework itself has to, much like we look up classes and resources through the version folders, the framework has to look up manifests, supplemental manifests through the version folders too, and use that to replace parts of the metadata of your module. But again, much like the purpose here is to provide alternative implementations of classes, not to add new functions. The practice is the true here. You really shouldn't use this feature to add new function to your bundle. If there's new function, release a new version. So in addition to the bundles themselves that can be multi-release, we have bundle class paths. So inside your bundle, you can have other jars, right? So it gets deeper. And of course, those jars themselves could be multi-release jars. And so we'll actually look inside those things to see if they're multi-release. And if they're multi-release, we'll of course treat them in that same way too. So it nests like a Russian doll. So we basically have the support in the spec. We still have to do the support for B&D to let you help you build and deal with these things. But I think the reality is, as we've seen in our brief survey, these things don't actually really exist much in the wild yet. So it's not a practical problem yet. But the spec rules are there and in place and implemented in the Core R7 framework. So if these things ever do appear in the wild, they'll be supported. So, because the platform is modularized and there's many different modules, we don't really know now what are the packages in the platform. So if we're a framework and we're trying to run a bundle and the bundle says, I require Java EE9, he might have been thinking that meant a certain set of Java packages, but we don't know. Like in Java 8, we knew exactly every Java package that was going to be there if it was Java 8. But you don't know that anymore. So the framework has to do the work to discover what's there, right? And fortunately, at least in Java 9, they now have a mechanism, an API set that the framework can call and introspect and find the list of packages. And so the framework can actually, do that computation and come up with the actual list of packages and publish it on the existing system packages property. So today, in the past, most frameworks have some sort of look-aside table. So if it's Java 8, here's the list of packages. If it's Java 7, here's the other list of packages, and so on. But we don't need to keep carrying those lists and maintaining them in the future now. We can ask the system, what's the list of packages? But the problem is, of course, that the list of packages can vary. It's not a fixed list. It depends on the modules that you configured into the Java command when you ran Java, especially if you have a JLink world where you might have JLinked out some of the modules. And so, as a bundle, how can I tell the framework what I use? Right? Because before I could just say I require Java 8, and that meant this set of Java packages. But now it doesn't mean that anymore. So I say I require Java 9, that doesn't say anything about the packages that might be there. So one of the other changes is we now added support that lets bundles import Java star packages. And so what that basically means then is that requiring Java 10 can only really mean that I have Java 10 class files. I need a Java 10 virtual machine, because it really can't say anything more about what Java packages I need, because it doesn't mean anything to require Java 10 beyond the virtual machine. And so bundles basically need to be in a position where they can put I import java dot blah. And then the framework can use that information to resolve your bundle. He can make a determination at runtime that your bundle needs these Java packages. I look at the system and I see that Java packages are there. Good, you're gonna work. I know that you're not gonna get any weird no class def found errors while you're running. But again, so this is basically a resolution story that says, can the framework prove that your bundle will run? And if you import all your Java packages, he can make that determination. Well, the version would come from the requirement on the EE. So you say, I require EE 10, Java 10, so that tells you the versions of the Java packages. Pardon? Well, it tells you what version of the Java platform, and then you use the import packages to say, further on, I'd like to say that I want java.util. Or some other package, which, that's not, the packages at a base aren't very interesting because they're always there, but some other package from some other module that may not be the java.awt, something or other. Okay, so that's the features that have been added to the core release. So, changing gears a little bit here, let's talk about some experiments that have been run around Java, OSGi, and Java modules, and what kind of integration stories might there be? So, first up, Tom Watson. How many people here know Tom? Tom is the the mad genius at IBM that implements Java OSGi things. He's the lead on the Equinox framework. And Tom also works on the Open Liberty team at IBM as well. So he's about as smart as you can get about class loading and modularity and OSGi. And so now Tom is getting smarter and smarter about modules too. And so he's been doing some really interesting experiments. So the first experiment, which I call the OSGi sandwich, Tom did back in 2016, I think. So this was right as the Java 9 specification and JPMS specification was reaching the endpoint, right at the 11th hour, right when things were looking pretty good. Tom ran this experiment, and it was interesting in several ways. And in fact, his discoveries, his conclusions, basically fed back into the spec process and led to a few changes. Not all of Tom's suggestions made it in, but quite a number of them did make it in and improved the API and some of the final design around Java Platform Module System. So the point of the sandwich here was it was a thought experiment that says, in a future, and there's some future where maybe Java EE, or now Jakarta EE, would specify that applications are modules. WAR files are modules, ears are modules, or however they shape applications in this future. But basically, the things that customers at enterprises are building are modules. And I need to run that on Open Liberty. And Open Liberty is a bunch of OSGi stuff, right? Open Liberty is built on the OSGi framework. All of the piece parts of Open Liberty are OSGi bundles. And of course, that Open Liberty would then be running on Java, 11, 12, 13, whatever, which is all modules too. So we have a sandwich here. We have some module bread on the bottom, which is the Java runtime. We have some OSGi meat in the middle, the Open Liberty framework implementation and all of the parts of Open Liberty. And then on top, we have another slice of bread, which is the customer's modules that he's written. And so Tom sort of cobbled together some experiments around that to see what it might look like. So this is Tom's first try at the OSGi sandwich. So basically this is all built on the concept of layers. Most people really don't see layers in JPMS because you think about modules. And when you run java -- module path, bunch of directory with a bunch of modules in it, name of my module, what really happens is that all of this stuff gets dumped into a layer up here above the boot layer. And so basically there's much like you would in class path, there's the boot class path loader, and then there's your application class loader. And you end up with two layers. And so Tom basically, above the boot layer, loaded, went Java-class path on Equinox. And so that got loaded into a layer as an unnamed module. And then all of the various bundles that represented the piece parts of Liberty were bundles loaded by the bundle class loaders of Equinox. And then, of course, Tom wanted to run some modules on top of it that might be for pretend customer applications written as modules. So he had to construct another layer. And so he created a layer into which to represent the bundles that were class loaded by Equinox. But the problem is this created a huge set of problems for accessibility, right? Because the bundles were loaded by class loaders created by the framework, they ended up in an unnamed module because they weren't real modules. And so even though Tom created sort of wrapper modules for them in the bundle layer, when those things tried to talk to other things, they couldn't. Tom had to have this really bizarre thing where he had to inject classes into the module so that that thing could call the add reads method to add a read connection back to the unnamed module. It was a mess, but it was an experiment and we learned some stuff. So then he had a second go at it. And so in the second try, he basically did it differently. He basically created more layers and actually created the class loaders in the layers so that each bundle was in fact a module and not loaded by a bundle class loader in the unnamed module. And so this improved things a bit, but ultimately I think Tom was unsatisfied with this experiment. It was too much work. It didn't really provide a lot of benefit. But we learned a lot. Tom learned a lot, and a lot of the things he learned, like I said, fed back into JPMS. So more recently, Tom has another experiment. This actually just came out a week or two ago. So it's very new, and you can check it out. It's called Atomos. And basically, the interesting thing here is more of a different approach. And so what Tom did here is he took all of the parts of the framework itself, all of the key bundles that would be installed in the framework, which would be your implementation of your application server, and he made them all modules. And he took all of those and then just put them on the module path and fired up a machine. And in fact, actually, Tom J-linked it all together into a compact machine, JVM image plus the piece parts. And so everything basically is, if you're familiar with POJOSR or Connect, it's basically flat class path. Everything is smashed together on one class path through the module path, right? So they're modules. And so Tom did this magic POM here. So Tom, in this project, there's this thing where he creates this image. So this is the image project. And he used this interesting plugin called Modetect, which is can take an existing jar, automatically generate a module info file for it, and jam it in there. And so he went through for all of the piece parts, like the framework, and created a module info file for it. And various other, there's lots and lots of exports. And he did the same thing for Felix SCR. So he basically, through this POM, generated, created module info files, run it through the tool, turned all these jars into modules, put them on the module path, J-link this whole thing together, and then he can fire up a go-go shell in an OSGi framework in a J-linked image. So it's basically sort of a one-shot deal. And of course, the other part of the experiment, which we have, I don't think there's any examples of in the repo here, is that you can, through another option, add other modules into the runtime through a command line switch. And so those will be created in a child layer, which sits above the main application layer. But of course, all of those themselves then have to be modules too. And each one of them, you create a special layer just to hold each one of those modules. So this is another experiment that's being run by Tom to figure out how do we interact this world. But this is a little bit different in that ultimately we're not using OSGi class loaders anymore in this experiment. This experiment is all module loaders. So if you can't translate the bundle into a module, then you can't play the game that Tom is experimenting with here. So that's interesting, and you might want to consider checking that out if it is interesting to you. Tools. So tooling. So another area that we can think about is what to do with tools, right? As I mentioned, we've got some new support in R7. We still need to finish the work in B&D to support multi-release jars and to generate the import package statements for java.star things if you're targeting Core R7. So these are known issues to work on in B&D. But what other things could be done in tooling in a joint OSGi JPMS universe that sort of exists today, right? Can we do tooling things that are helpful to OSGi peeps and Java module peeps, right? For example, could you automatically enrich the module info information through tooling support, right? If you have annotations that where you're using service loader things, why should you also have to go write the service loader things also in your module info file, right? Basically repeating type names, which you have to worry about refactoring and other stuff, right? It sort of flies in the face of all of the things that we do today with annotations, right? The whole point of annotations is to put them where you use them. But then module info sort of counters that because you also have to say the same thing over here in the module info file. So could tooling help us? Could we enrich the module info class file in the process of building the bundle through annotation analysis? I don't have to write this stuff in my module info. And shading of non-exported packages, right? If we're all together in one class loader and non-exported packages are a source of conflict, can tooling help us by automatically shading those things? So those are my thoughts on OSGi and the Java Platform Module System. So thank you, and I think we're out of time. So for those who are more interested in more thinking on this topic, immediately after this, we're going to have a panel discussion. So we'll have a few people that are involved in the OSGi and the Java module space to sort of think and explore and talk about what can happen and maybe take some questions from you guys. So that's up next.